Okay, everyone, I wanted to take a moment to talk about some of these opens and shorts. They seem to be confusing us a little bit, and so I wanted to quickly do a quick rundown of what happens in circuits. I've drawn a parallel circuit here, but what we know about parallel circuits is that every time we look at the parallel branch, we always have the same voltage at all the parallel legs. In this instance, we've got a battery showing us that we have 10 volts. Here's my ground reference, and I have a number of different circuits that are in parallel with each other. I'm not going to look at the current here, or power, or anything like that. I'm just concerned about the voltage. So if we were to just look at one circuit, let's say we were just to look at this one right here. We would just have a series circuit, and I would bring this over, and my R1 would have 10 volts. If I came down here, I would have 0 volts. If I came up here, I would have 0 volts because my leads don't have any voltage potential. Only something that has resistance can take voltage and current. This is just a conductor, this wire right here, okay? So if I measure my battery, I have 10 volts. If I follow my wires along over to my resistor, my drop is here at R1. And so I'm just going to measure my voltages quickly on this sheet. All of my opens are infinite resistance. The electricity is not making its way across. All of my shorts have no resistance. Okay, and we'll just call the resistors 1K, but I'm not even looking at currents and all of that. Okay, I'm just looking at voltage. Here at R1, I have 10 volts, and I'm going to mark that in red so it's a little easier to see. I have plus 10 volts. Should be plus 10.00, but my board is small, so I can't do what I need to do. Okay. If I come over here, actually, if I stretch all the way down, I have test point 5 and test point 1. It's the same thing as being over here on my battery. My wire is electrically the same all the way. My wire is the same all the way up. My ground wire is a ground wire all the way up here to the bottom of R1, to the bottom of R3, to the bottom of R5, to the bottom of this switch, to the bottom of R7 and bottom of R8, test point 1. It's all the same wire. Same thing at the top. I'm connected to 10 volts electrically. Doesn't mean I have 10 volts, but my top of my battery is connected to this resistor, to the top of R2, to the top of R4, to the top of this switch, to the top of R6 here. Okay. So if I move over to my next circuit, I have 2 resistors in series. Okay. I'll still have 10 volts here. Okay. But I have equal resistors. I said they were all 1K. So if I measure here, I'm going to get 5 volts. If I measure here, I'm going to get 10 volts. If I measure from test point 2 to test point 5, I'm going to get 5 plus 5 volts. Okay? So 5 volts across each of these resistors because they're equal. 5 volts, 10 volts. 5 volts, 0 volts. 5 volts, negative 5 volts. Okay? All right, so V2, my voltage across R2 is 5 volts. My voltage across my voltage of R3, V3, plus 5 volts. Okay. Across both of them, it's 10. Where am I recording that measurement? I'm recording it as test point 5. My ground to test point 5, it's the same all the way along, all of here. So that's also plus 10.00 VDC. There, I've got enough room to squeeze it in there, which is the same as across my resistor 1. Okay, now I move on. I've got a trick in this one. Should have drawn it in. I'm shorting out resistor 5. Okay, I want to know, what is my voltage across R4? What is my voltage across R5? So if I come and I bring this over here, what's my voltage? Okay, I'm shorting out resistor 5, so it's the same thing as R1. I have 10 volts across R4. Okay, R5 gets nothing. It's plus or minus 0 volts DC. Okay, because it's shorted out. Can't have any voltage here. I have to obey Ohm's law. If I have no current going through R5, I have no voltage. I know I have no current. So in my Ohm's law, it says my resistance times my current equals my voltage. If I have 1,000 ohms times 0 amps, that's going to give me 0 volts at R5. So I know that all 10 volts is going across R4. Okay, let's look at our switch. I have a switch potential of 10 volts across this switch. If I closed it, it would be a short. It would short everything in here out. So I've shown it as open. My open here is 10 volts. My short here, I'm just measuring a piece of wire. I have no resistance on this short. Nothing between TP3 and ground. So my test point 2, that was 5 volts. Test point 1, let's do that one. I have 0 volts. It's the same piece of wire. So plus or minus 0.000 volts DC. Test point 2 was plus 5 volts DC. Test point 3, plus or minus 0 volts DC. Test point 4, we're moving on. Okay, so what we want to do next is I want to do a quick reminder of how parallel resistance works. It's the inverse of the additive inverses of our parallel resistors. I take the resistance, I make it an inverse, I make it an inverse, I make it an inverse, however many they are, and I add the inverses together, and then I flip it back around to create the new inverse. So if we were to look at how does that work for our current circuit, let's just do a quick look at that here. Hopefully I don't mess up my stuff too much. 1 over 1,000, so I have 1,000 ohms, 1 kilo ohm, is equal to 0.001 or 1 milliamp. So our circuit is 2 resistors in parallel. So 1 milliamp plus 1 milliamp equals 2 milliamps. And then 1 over 0.002, what is that? If I inverse that, I've got 0.002 over 1. 1, 2, 3. 1, 2, 3. That's 2 1,000ths, or no, I did that wrong. I'm sorry. 1 over 0.002. That's 2. Sorry, I don't inverse it again. That's 2, 1, 2, 3. 2 over 1,000 is the same thing as 500 over 1. So that means I have 500 ohms. Okay? So 500 ohms it is. If I had one resistor going through here, which I don't, but for current figuring purposes I do, I have 500 ohms. Okay? That's my circuit equivalent. So I have 1,000 ohms up here, 500 ohms up here. That tells us how to outlay the currents. So that means if I have 6.666 volts up here at 1,000 ohms, that means I have 6.667, should be 667 volts and milliamps. Okay. In a series circuit, now I have to say the same, but when I get to this node, I'm branching out and I'm splitting my current. So each one of these 1000K resistors will have 3.333 milliamps. 3.333 milliamps. Okay. That's how we get our voltage down to 3.333 volts here and here. My test point 4 then is 3.333 milliamps, or 3.333 volts here. I have a test point, let's see here. So my 0 to test point 5 is 10 volts. This is 3.333 volts. This is 6.667 volts DC. So my voltages across these two are 3.333 volts DC. And then I have 6.667 volts up here. Once I figure my voltage here, I can figure my current, and I know how to divide my current when I get down to my series circuit. Okay. So what I've seen is that when we come to parallel circuits, sometimes people are confused about what happens. Remember, this piece of wire right here is all the same electrically. And then down here, this ground wire all the way up in here, where this is wired, electrically these are all connected. If we shut off power to this circuit and we ran to ohm something out to look for our sound beep, I could touch anywhere on here and I would get beeping. I would get continuity. Okay? So hopefully that helps clear up a little bit more about where our opens are and where our shorts are. When I say that a diode is a no-go, it's just like this. It's wide open. It's not conducting voltage or current. So it's not taking any voltage. It's not conducting current. It's open. When I say that something is a short, it behaves just like this. It conducts because there's no resistance. Okay?